started. Yeah. So good afternoon, everyone. So
Good
today,
afternoon, sir.
good
Good
afternoon.
afternoon, sir.
So today is our second lecture on the course data structure and algorithm. Today our topic will be on 1D array basic operations. We shall start with revisiting insertion operation. We will understand logical development of insertion, and thereby we will do the algorithm development. Okay? And if time permits, we will do understand the logical part of deletion operation. I have shared my screen. Hope you can see my screen.
Yes,
Yes,
sir.
sir, we
Yes.
can.
Yes, sir.
Okay, just have a brief overview, or revision on what we just started in the last class, introductory class. So the basic array operations, which we shall be understanding in detail, that is insertion operation, deletion operation. Uh, okay, and while doing so, we will be inherently doing the traversal operation also. Okay, and display operation also. So array is a data structure where the elements of the array must be of same data type. We can't store elements of various different data types into a single array. And array is the data structure where the array elements must have contiguous, do have contiguous memory allocations. Okay. So in insertion operation, consider this example. Okay, so in this operation, let's say already there are four elements are there stored in the 1D array, 10, 13, 20, and 16. And in other positions, the values are shown to be 0 because we want to assume that if any location of an array cell is containing 0, that means we have to understand that location is empty. No meaningful information or data is stored over that location. And if any cell is containing any non-zero value, then we will understand that that position is already occupied, by some valuable information or data. Okay, also we want to make a second assumption that the size of this 1D array will be fixed throughout the various operations to be performed on this 1D array. Okay, so for insertion, we may have two cases. For example, case one, we want to insert an element, of course non-zero element, not we do not want to insert any element whose value is equal to 0, because 0 is actually meaningless for our operation, for simplicity. So insert an element, non-zero element, at any intermediate position. It may be first position, or it may be last position, or it may be any intermediate position. Okay, so provided there is space available for the insertion, means if we know, we should have a prerequisite knowledge about the size of the array. For example, here 4, 9 is the size of the array. So the capacity of the array is to store maximum 9 elements. So if the array is full, capacity is full, already there are 9 non-zero elements. We can't go for further insertion. That is not possible. So that is the meaning of that. If there is any space available or not, means if the number of non-zero elements present in the array is equivalent to the array size or not. If is equivalent to array size, the array is full. We can't go for no space left. Okay, no insertion possible. That actually comes under case 2. Okay, but assuming that if there is some space available, at least one element in the array must be 0. That ensures that at least one vacancy we have in the array. Then we can have at least one insertion. So let's insert an element. The element is suppose n, small n, at some position, let's say small p. Okay, uh, and capital N is the size of the array. Okay, so then and for example, we want to insert for p equal to 2, for example, and let's say n equal to 40. Okay, so as we are a programmer, so from programmer perspective, p equal to 2 means this location. So this is corresponding to p equal to 0, this is p equal to 1, p equal to 2, and the last index for the last element, p will be equal to 8. So p equal to 0 to p equal to 8, total 9 elements are there. So for p equal to 2, we want to, at p equal to 2, we want to insert a value n equal to 40. And we have already a scenario that that position is not vacant, but we have space available for possible insertion. So if the location is not vacant, or if it is vacant, then fine, but if it is not vacant, we have to create a vacancy over that position. So for that purpose, what we are doing, that we are doing a right shifting of all the elements starting from this position and ending with this position, the penultimate element. Okay, so we will do right shift of this 20, we will do right shift of value at this position, we will right shift this one, we will right shift this one, we will right shift this one, and finally we will right shift this one. And if you do right shift of this one, it doesn't matter, it will be automatically lost. Okay, and if you do not do right shift of the last element, the second last element will automatically replace the last element. Okay, so to save one step, we can do what, we can do right shiftings of the elements starting from this position index to the second last position index. Okay, okay, so that means if now, okay, so total 9 vacancies are there. So this is correspond to p equal to 2, and this is correspond to p equal to 8, and this is your p equal to 7. So now we have to do right shifting of element stored at this position, and we will do continue that process till we reach this position. So all the elements in this region have to be right shifted by 1 unit. So how many elements we are right shifting, if we can count that part. So this is your p, the user given position index, that is your p, and this is if the size of the array is capital N. So index of the first, this element is 0, index of this element is actually n minus 1. Okay, so that 0 to n minus 1, we will have total n number of elements of the 1D array, and the index of this element is n minus 2. So for I is equal to p, so for I equal to p, this thing, 2 n minus 2. So for all these I values, we are doing the right shifting of the elements. So how many values are there? How many elements are there? Make a count of it. So n minus 2, as n minus 2 is greater than p, it's a smaller value, it's a greater value. So n minus 2 minus p and then plus 1. So this is the n minus p, n minus p minus 1. So what is this thing? So this is the number of elements, this is the number of elements which are being right shifted for a single insertion operation. Okay, n minus p minus 1. Fine. So okay, so we are doing right shifting of the elements. How many number of elements we are right shifting? N minus p minus 1 number of elements. That's very clear. Now where to start the right shifting? Can we start right shifting from the left, from position P? The answer is no. Why? Because if we start right shifting of the element from index P, so let's start that. So if we right shift that element 20, so 20 after right shifting, it will replace the 16 value, which was not preserved, okay, before the right shifting. So this value will get lost. Okay, so that's why we can't start right shifting of the elements from the position of insertion. We have to right shift the elements n minus p minus 1 number of elements from the right end. What is the right end of right shifting? So this is the element. This is the element. Okay, this is the element which is going to be right shifted first. So we have to start right shifting from this position. Then so it will look like this. So after right shifting, this is coming here. Then we right shift this element, so to bring that element here. Then we are right shifting this element to this position. Then we are right shifting this element to this position. Then we are right shifting this element to this position. And finally, this is the last element which is to be right shifted. Okay. So how many are there? 1, 2, 3, 4, 5. 5 right shifts. 5 elements are being right shifted. According to the formula, your n is, for this case, n equal to 7.
8 minus 2 minus 1, 5.
So what is the value of n? N is here.
N is 9. 9.
And p is equal to your 2. So n minus 2, 7
5.
minus 1, that is 6. So 6 elements are there.
6.
Yes, 6.
Okay. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. It's very good. Fine. So the two information we got from this thing. Number 1, n minus p minus 1 number of elements are to be right shifted. The elements are having index I equal to p to n minus 2, where p is the position of insertion from programmer's perspective, not layman's perspective, because we are considering index of the first element. This element is to be 0. Based on that, everything is being considered. And n is the number of elements, size of the array. Okay, fine. Next, second point is the right shifting has to be performed from the right end. Right end means from the position index p equal to n minus 1. P equal to n minus 2. So we will start from this position and will eventually end up the right shifting at this position, I equal to p. Okay, so this is very important. Now, once we do the right shifting, okay, then whatever is the value available here, it doesn't matter. Simply, we will assign the user given value 40 at this designated position. So 40 will appear at this p equal to 2 position. And after that, the picture will look like this. 10, 30, 40, 20, 16, all zeros. And you can see how many spaces are available in the array. That is equal to the number of zeros present in the array. So here, 5 zeros are there. That means 5 spaces are possible. That means 5 elements more can be inserted in the 1D array. So all this information you may compute if user wants to have. And after in single insertion, 1 space will be less. So now here number of zeros is 4. Okay, fine.
Sir, is there any formula to calculate the number of empty spaces after right shifting?
What?
Is there any particular formula to calculate the number of empty spaces after right shifting?
That is the number of zeros. You may find
number
out.
Of zeros.
Just this is not required any formula. You actually traverse through the traverse along the array, entire 1D array, starting from, let's say, I equal to 0 index, that is 0th element, to I equal to n minus 1. So you traverse along the entire 1D array and just check using an if condition. If your AI is equivalent to 0, then it's a vacancy. It's an empty space. You make a counter C++. But initially we have a C equal to 0. So if you do C++, then after the completion of the traversal throughout the 1D array, the final value of C will give you the number of spaces available in the 1D array.
Okay.
Yes, sir. Yes, sir.
Okay, so now if the array is full, no space available, then there is no further insertion possible. Okay, so no zeros is there. So how to check whether there is any space left or not? So I just told you right now that count the number of spaces. If now there is no space available, or if the number of non-zero elements, then you have to do AI not equal to 0. So if the number of non-zero elements is equal to, okay, size of the array, then you are deciding there is no space available, no insertion possible. So these two cases can be
Hmm.
easily implemented.
Yes.
In C.
Let's coming to algorithm development. Algorithm, what you are new to write, you have to very much understand how to write the algorithm. We know how to write a program, but algorithm is not actually a program. Okay, so this is like a layman understanding. This have to be written so that in layman can understand. Layman means they can be any mathematicians. Okay, because programming is based on logic, and logic will be developed based on the mathematical concepts. Okay, and aptitudinal skills. So mathematicians or some persons who have the prerequisite of aptitude. So those people can easily understand your algorithm. Based on that, you have to write the algorithm. No syntax. Okay, at all. So okay, so let's start with this. So what information we must have from the user? User must provide the value of n. That is, what is the value to be inserted? That is your small n. And where that value n to be inserted? That is the position index small p. Okay, and you may ask the user uh, because first time, for any intermediate operation, you do not have to ask the user, please provide me the 1D array size. No, for any intermediate operations. For beginning of the operations, you may require, okay, what will be the size of the 1D array? So at the beginning of the program, you may ask the user, you may not ask the user, that depends on you, it's not a problem. So capital N, that is why capital N is not taken as the user input in this case, in the algorithm. We assume that we already know the capital N. Okay, so capital N is the size of the array, and what we are doing initially, that is the programmer. Programmer is doing what? Programmer is actually setting all the values, resetting all the values of the 1D array to 0 to ensure that all there is the array is fully empty. Okay, to set all AI is equal to 0. What is AI? It's a symbol. How to represent a single 1D array. Okay, so if we denote, if the array name is A, if the array name is A, then any element of that array is denoted by A suffix I. Okay, what is I? I is the position index. Okay, so we here specify that I is starting from 0 to n minus 1, a closed interval. So I not equal to I belongs to. I is an integer, belongs to 0 to n minus 1, closed integer, closed interval. Okay, so a0, a2, dot dot dot, a n minus 1. So n number of elements are the contents of the entire 1D array. 1D array is like is in this case is a vector. So these are vector components. Okay. So set all ai equal to 0 for I belongs to 0 to n. Here we have given open interval. Okay. So 0 to n minus 1 closed interval. Either 0 to n minus 1 closed interval in both the ends, or this one. So now we are calling a function insert air first bracket. Within brackets we are passing the arguments. One is the value of the element to be inserted, another is the position of insertion. Okay, and as a good programmer, so these are few small things I would recommend. That is, while naming a variable, you know how to, what are the rules to write a variable name, to write a function name, right, etc. So now onwards, we are in an advanced situation, data structure algorithm, and maybe in the future design of analysis of algorithm, Java or object-oriented program, etc. Something. Okay. So whenever we want to solve a group problem, a real life problem or something, a bigger problem, so then it is better to write names of the variables as well as the functions. Okay, uh, I mean as convenient as possible, so that any layman can understand from the name itself. Okay, this is the purpose. This could be the purpose of that name of the variable or name of the function. Okay, and in while naming so a function, see, two words we are clubbing. Okay, first is insert, another word is array. Insert array. So the first subword is starting with a small case I, but the subsequent words which are being clubbed after the first word, their first letter should be capital. So this is a good convention which programmers follow. Okay, in industry, software industry, wherever. So insert array, np function call, and then we are coming here. For better understanding, whatever variable names you are using over here, you write here as a comment. N is the element to be inserted. P is the position of insertion with starting index equal to 0. And A, what is A? A is the array of size n. AI is the ith element of A, where I is 0 to n minus 1, closed interval. So everything I am mentioning over here to make the layman clearly understand about these things. Okay, what are the symbols about? Now coming to main function definition in algorithm. Okay, so insert air np semicolon. This is the and now this is the body of the function. Okay, definition of the function. So this is actually comment. This is not the part of the algorithm. I mean, this will not be executed. So what we are doing, we are first checking whether insertion is possible or not. I mean, case number 2, if the array is full or not. So if count A, so yes, that thing we may write directly over here, this concept. This concept, logic, we can directly use here. But, we want to add that as a feature, okay, count feature. Anytime user may want, okay, what is the count of the array? How many elements are present already in the array? User may want. So that's an extra feature. And that extra feature we are designing, we are developing, by defining its own function. Okay. So for better modularization, we know why we actually use functions to make the program more modularized. Okay, to more flexible. Okay, so because if we delete the count part, so I mean we don't have to change a lot in the main program. So that is the utility of advantage of using functions. Okay, so if count of A means the function definition for counting array elements, non-zero array elements. Okay, so if count A number of non-zero elements is equivalent to n, where n is the size of the array, clearly we can understand that insertion is not possible. How to write that? If, then display this message within double quotation and end if. Okay, fine. Else do for this is your right shifting. So I just told you the logic. The logic is you have to do right shifting from n-2 to p, or if you do n-1, or if you start also n-1, that is also not a problem. Okay, so for I equal to n-1 to p plus 1. Okay, in steps of 1, 2. So in steps of 1, 2 means this is the incrementation part in steps of 1, 2. So here in this case, we are decrementing the value I by 1 always in every iteration. That's why it is mentioned in steps of 1. It may be required that I may be decremented in steps of 2. So then you have to write I in steps of 2 accordingly. So for I equal to n-1 to p plus 1 in steps of 1, do this. What is AI equal to A minus 1. That is written in this way. If you simply write ওই লাইনটা না লিখে যদি এটা লিখতে যে AI is equal to AI minus 1, right, then also it's not a problem, it's okay. Okay, but here I am showing you left arrow means this is going to replace the left hand side. The right hand side is going to replace the left hand side. To emphasize that replacement or assignment operation, what we normally understand, what do we mean by assignment operation? What does that assignment operation means? It's not like mathematical equality, left hand side equal to RHS or RHS equal to LHS. No. In mathematics, LHS equal to RHS means we can swap the position, RHS equal to LHS or LHS equal to RHS. Both are same meaning. But in case of assignment operation, LHS equal to RHS is not equivalent to RHS equal to LHS. Because in assignment operation, the right hand side is going to replace the left hand side. The right hand side is going to be assigned to left hand side. Okay.
So A minus 1 to AI, that is the right shifting.
Right. Okay, AI equal to A minus 1. See, we are starting from N minus 1 to P plus 1. Okay. N minus 1 means this one. N minus 1 means this one. So what is AI? AI first, when the first iteration, I is equal to N minus 1. So this is A N minus 1 is going to be replaced by A N minus 1 minus 1, N minus 2. So A N minus 1, this position is getting replaced by its previous value.
Yes.
That is the meaning of right shifting. Yes or no? A N minus 1 is going
Yes,
to
sir.
be replaced by
Exactly.
A minus 2. Right. So that's why it is done. Okay. And the last operation, when I equal to P plus 1. P plus 1 means this is your P plus 1. This is your P. So A of P plus 1, AP plus 1 is getting replaced by its previous value, that is
A of P. A of
P. A of P.
yeah.
So for the first iteration, A N minus 1 is replaced by A N minus 2. That is this red colored right shifting. And the last operation of right shifting is AP plus 1 is getting replaced by A P. That is this red colored right shifting. Understood?
Yes, sir.
Yes.
Yes, sir. Yes, sir.
Right. So how many possible values of I for which this for loop is getting executed? The last index is P plus 1. The first index is N minus 1. But this is greater than P plus 1. So let's calculate N minus 1, P plus 1. So N minus 1 minus P plus 1 and plus 1. So this is the total number of I values for which the for loop is activated. So this is going to be your N minus P, okay, minus 1,
Minus 1.
minus 2, plus
N
1.
minus P minus 1.
Right, so this is the same number of counts which we have earlier derived. Okay, so it's not a problem.
This is the generalized formula, N minus P minus 1.
Right, okay. So end for AI is then, okay, right shifting are done, all the right shifting are done. So then simply what you have to do at this position, হ্যালো আমি ক্লাসে আছি একটু পরে কথা বলছি so AI so okay, fine. So after, see what we are doing after the right shifting, what we do, we want to simply assign the value user given value n into the position of insertion. And now what is the how to access this position? AP. So this value is AP. So what we are doing, AP is assigned by a value n. AP left arrow n. AP left arrow n. And you know, we are using a tricky thing that here it is AI. In this situation, actually I equal to P. So if you do not want to
Yes,
think
sir. Yes, sir. In the for loop,
that much
we use.
deeper into the code itself, okay, logic itself, then you can simply blindly do AP left arrow n. That is not a problem. But after this completion of this for statement for loop, what is the last modified value of I?
Sir, P.
And that is going to be your P. The last successfully executed value of I is P plus 1. And after the completion of the for loop, there will be an unsuccessful execution of the for loop, due to which I value will be further decreased from P plus 1 to P. So last modified value of I is P. So that's why in the situation I is equal to P. That's why using that modified value itself, with that modified value to do this operation, assignment operation, AI left arrow N. And that's all, insertion is done, and else your function definition is complete. And for counting purpose, it's 120, okay. For counting purpose, function definition for counting array elements. So simply, let's say I is assigned to 0, count A. Count A means it's a counter variable name, count A is equal to 0. So while AI is not equal to 0, do count A equal to count A plus 1. We can't write here count A plus plus. It's a syntax. So what we do, count A arrow, count A plus 1. You may also write count A equal to count A plus 1. That is also fine for algorithm. For as a beginner, we want to write algorithm from very fundamental perspective. That's why I'm showing you the original algorithm writing rules. So count A, left arrow, count A plus 1. Arrow means the right hand side is going to replace the left hand side. And then return count A. That's all. So it is counting the total number of non-zero elements which is being used over here. Understood?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Okay. So any question up to this you may ask, because the time is already over.
Sir, just one question.
Yes.
স্যার একদম লাস্টে যে রিটার্ন কাউন্ট করেছেন ওখানে আমরা ডিসপ্লে কাউন্ট এমনি লিখতে পারি একদম লাস্টে
Count করে আমার লাভ কি? Because we are calling the function count A so that we readily get the value, what is the number of elements. So this function must return the value of the return the number of non-zero elements to the calling statement.
ওকে স্যার ওকে
Here the functionality of the count function is to count the number of elements and return to the calling statement. That's all.
ওকে স্যার ওকে
If you want to display the number of count elements, you can do over here. You call the count function, and there you display the number of.
we
count
can
elements.
display the yes. Okay.
Any other question? I guess no. So I'm stop presenting. We will have a very short quiz. Just it will take 2-3 minutes. I'm sharing the link. ভালো লেগেছে আজকে? Did you like it?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Yes sir. Yes sir.
You-
Yes, sir.